Hello everyone, welcome to Card Pro Max. So in this session we will basically cover the generative sheet metal design. Okay, so what is generative sheet metal design or sheet metal design? So basically sheet metal design is a process of designing industrial sheet metal parts and in the intricacies features like bends, cutouts, stamp, flange, etc. So there are different types of sheet metal process like blanking, drawing, deep drawing, bending, folding, punching, forming, stamping, shearing, slitering, etc. So generally the sheet metal design is a new generation CATIA product which is dedicated to the sheet metal part. It offers a high productive and a intuitive design environment. It allows to fold and unfold the representation of the part, and the more one more advantages of the sheet metal is we can work sheet metal part with other application like part assembly and drawing generation. And in the sheet metal part there are many standard feature like stiffener, stamp, shape and sweep features which is reduce the design error. Okay, so how to access this sheet metal design? Okay, you just go to the start mechanical design and here you will get the generative sheet metal design. Okay, start mechanical design, generative sheet metal design. Okay, then it will ask to you the name and you will directly go to this sheet metal design, or else you can go with this. Okay, not only, and if you want to make it used frequently you can do this as a favorite, this workbench set as a favorite, like here generative sheet metal design you make as favorite so that it will comes to in your favorite list as well as in your welcome to the KTB tools. So what are the general procedure of the sheet metal design? So in the sheet metal design, first thing is you need to add the sheet metal parameters. You can see here sheet metal parameters. Then we will create different types of walls. Okay, that is the first level of a feature in sheet metal design. Then after creating the wall, we will go with the blend. Okay, we'll go with the blend feature. Then we will remove the unwanted element or unwanted feature from the parts. Then we will create the flat view what we are create the flat view what we designed. Then according to your requirement we will go for thickness, modify the thickness and wall size. Okay, so this is the general procedure how we will basically follow the sheet metal design. Now the first thing is sheet metal, but before creation any sheet metal design you need to set the sheet metal parameters. Okay, so sheet metal parameters is driven by basic parameters like your standard thickness, bend radius. Okay, then bend extremity, no relief, square relief or round relief you can set in the beginning itself, or you can keep the k factor allowances. Okay, and remember these two is info, optional. Bend extremities and bend allowances, these two is optional, but this you must specify the default bend radius and thickness in the parameter option. Okay, it will guide throughout the design, like your thickness would be uniform throughout the design and the bed radius will also same as the uniform throughout the design. So the most important thing is you must be specify the default bend radius and thickness, and other parameters like bend extremity and bend allowances is your optional. And you can see the k factor is depends upon the depends upon the material formula. So whatever the, if you will go with the sheet one, sheet file lot. Mm, yes, you can see I have set the aluminum table. Okay, okay, it is by default it will take you the standard is aluminum, and here the bend radius it is taking, and it will take the bend extremity and the K factor directly from the. If I will change this now, you can see the bend allowances is K factor it is 0.47. If I'll change with the material, here let I will change the material aluminum only, but here go with the thickness 3. Yes, you can see the K factor is changed, and it has one formula also. You can see this is the formula which is set default in your uh, K factor. Okay, K factor is basically calculated in this formula only. Okay, so this is how you will set the parameters with a standard. Okay, so you have prepared some standard for in different thickness, what will the bend radius and what will be the K factor, it which you can set your organizational standard also. Okay, now the thing is that after that we will go with creating the wall. Okay, and one thing is whenever we are creating this one, if you will go to this is part object, and here it is view, you will find view. Okay, part body, part object and view, here it is flat view, means the fold unfold view. Okay, if you want to deactivate it, you can deactivate, so that if you do not need any access of unfold view, you can disable this calculation. Okay, so after deactivating this flat view calculation will be increase the feature generation speed. So whatever the feature you will say, you will create, if you want to create a feature, it will generate the feature very fast. Okay, and you can see now if I will go with this fold on fold view, it won't be possible to fold or unfold. Okay, again if you want to go for this one, just go to reactivate. Okay, like that you can define the view for while generating the before generating the sheet metal parts. Okay, now let's discuss about, see, after the sheet metal parameter shared, it is activating the um, features like here walls, then or rolled walls, then bending, cutting, stamping, view, transformation features. See, all these thing is set now, and see it is activated. Okay, now we'll see how many types of wall. Okay, the first wall is always created in the, remember the first wall, whatever the thing or 3D element you want to create, or a 3D model you can sheet metal design you want to create, that should be lies in the in a sketch. It is same as with your part design. Okay, we need a sketch to do the wall. Okay, so it can also created in a extrude roll wall, profile wall, or a hover operation. You can see here the wall can be created by wall, then extrude, then here rolled wall, then hover operation. Okay, so let's discuss about the very basic, which is similar with the your part design as well as in your generative shape design. Okay, let's start with this extrude. Extrude means it will generate the wall or generate the 3D model with respect to the sketch. Okay, with respect to profile. So they in this generative shape design, one main difference is the extrude is only possible in the open profile. Okay, extrude is only possible in the open profile. You can, so if I will go to this extrude, and I'm just creating the extrude. So now you can see I'm able to do the extrude, and it is taking the original. Here in like the part design, you will fix the vertex one. Okay, the vertex one is fixed, and here you will find the limit one, limit limit dimension, limit 1 and limit 2. Okay, you can define the dimension as per your requirement, and here you can go with this sketch at the extreme position or in the middle. Okay, in the neutral position you can go with the neutral position. It should not creating an error to modify the input parameter. Okay, okay, so input parameter is not, so sketch should be in an extreme position. You can do the mirror extend exploded mode, so there is no thing, no exploded mode, so mirror. And automatic bend, you can see if I will go with the automatic, if I check off this automatic bend, this bend operation is not performing here. You can see it is not performing the bend, but I want some bend here. Okay, so what you need to do is you just create the automatic bend, and here you can define the left or a right extremity. Okay, if I will change, there are different types of bend relief. Okay, one is no relief, minimum with no relief, you can say no relief. Okay, then one is here, this one, select the extremity type. Second one is minimum with square relief. Okay, in the right side also, in the right left side I will also define the minimum with square relief. Okay, just close and preview. Okay, so it is not coming, so it is like it will create the bend while creating the extrude. Okay, then, and remember this extrusion is only possible when it is a open profile. Now another type of extrude feature like a roll wall. Okay, roll wall is only possible when you have a round type of structure. Okay, like a cylinder. Okay, I'm just going to open one of the roll wall. Yes, and this one we can perform in open profile as well as in closed profile. Okay, so you can see when I will go to this, it is similar to the part design. Okay, I'll go to this mirror extend or symmetrical thickness I can give, or location end point or fold on point. You can define the start point. I can define the start point. Okay, and here you can find the types of limit like dimension, up to plane, up to surface, mid plane, like that you can define here. Also in the second limit also you can go with the plane or dimension as per your requirement. You can give and preview. You can see it is creating the roll wall in open profile. You can go with just close profile also. I will change this one to close profile. Let I will change to close profile. You can see it is creating this with the respect to that thickness, sheet metal parameters thickness. Thickness is 3 and radius is 4. Okay, now, okay, here you can define the start point also. Okay, now if you want to unfold it, you can go to unfold with respect to that point. Okay, it will unfold and unfold, fold, unfold by using this one. Okay, now I was talking about this setting. Okay, see view, I don't want the flat view and I deactivate it. Now I will try to unfold it, it won't be showing. You can, it will show you the modify view. You want to visualize the unfold view. Unfold view is currently inactive, so for active, so what is the advantage of this? If you disabling this flat view calculation means while disabling this or deactivating the flat view calculation, it will increase the feature generation of the sheet metal part. So in the time of sheet metal part, you can de uh, deactivate or activate as per your requirement. Okay, now now the next one is your, okay, creating the wall. Okay, so creating the wall. So as I said, for creating the wall, we need a, I'm just click on this wall definition here. It is asking a profile. Okay, it is asking a profile. Okay, for that I will just creating one of the profile, and remember the profile should be closed. While creating the profile, you should be closed. If I will go with the open profile, let I will go with this let I go with this open profile and go with this. You can see it is showing the selected profile is not correct. The profile should be closed. Please redesign the profile. Okay, I'm just again enter to this sketch. I'm just click on the wall, select the plane, and I will just create one of a close profile. Okay, now it will take the wall and the thickness by default to whatever the thickness you have given in the sheet metal parameters. Okay, now here profile is there, and here it you can see the sketch at the extreme position. The sheet metal wall will be generated at the extreme position, and here it is in the middle position. Let's see what is that. So if I will check means on ahead this sketch, you can see in the extreme position the sheet metal part is generated. You can see in the extreme position sheet metal part is generated. If I will go with this sketch at the middle, you can see in the middle, I'll just on ahead this sketch too. In the middle, have the sheet metal part, each wall is generated or created. Okay, and you can give the offset if you want to increase, you want to set this is wall in some offset value. You can go with the offset value by giving the dimension of this. You can go with the inverted side, outside, in or downside, as for your requirement preview. Okay, now here another option is here tangent to. Okay, for that I have one good example, that is tangent wall. Sorry, not this one. Okay, okay, so for that I have just creating one, I am just creating one of the profile. I want to connect these two by using the wall, okay, I'm just connecting the rectangle. Let I'm creating connecting the rectangle, this one, uh, right click, this one. Okay, now you can see I have connected one profile. I want to make a the whole one. Okay, if I'll go with this normal profile and go for invert side, and you can see it is coming. Okay, but it is not connecting to that one. The wall is separate. Okay. Mm, if I will hide this. Okay. Okay, if I will go with this deactivate, only this deactivate feature is there. Okay, so it is not taking the whole, it is not merging with the main sheet metal part. I want to merge it this. So what you need to do is you need to give the tangent preview. Okay, you can see it is merged now, there is no gap. If I will go with the deactivate the feature, if I will go with the deactivating the feature, okay, it's coming, but yeah, you need to understand that this is how we can merge the component or merge the sheet metal part by using the tangent option. Then okay, then the next one is your wall on edge. Next one is your wall on edge. So as the name is suggesting, so it is telling we need to create a wall on edge. So here there are two types of edge creation, means wall on edge definition. One is automatic. By automatic it will take the wall on edge, and one is sketch based. Okay, so if I will go with the automatic, it will show you the height, angle. Okay, height and angle with the dimension, and extremity you can define your extremity. Okay, let okay, now you will understand the wall on edge automatic. I'm just selecting one of the edge. You can see it is default, it is taking the height 25. You can give that, increase the 25, or you can reverse the position also. And here you can see some limiting is there. If I will change the offset value, you can see it is starting from the whole edge. Okay, and here it is a clearance mode. No clearance means it will directly, you can see there is no clearance, it is creating the bend from here, the no clearance. Okay, if I will give the mono clearance, okay, mono clearance means it is giving, creating the bend will create, or a wall will create at the end. Okay, mono clearance, now it is zero value. If I will give the 2, you can see it is starting with this one of the this. Okay, if I will go with the y direction, here you can see y direction automatic, the clearance value is 4, it is taking 4, means here it will 2, and in the top also it is taking 2. Okay, let I will delete, deactivate this, and I will give it the 6. You can see it will be increase, and that also increase. Okay, so white clearance, no clearance, you can define as per your requirement. Invert the material inside the material. So invert means inside it and outside it. Okay, blend dimension, it will come directly, and here you can define the extremity. So left extremity, let I will go with the left extremity. I will give some extreme value, let 5, and this one also 5. Okay, and okay, okay, -5, -5, here it is -5. Okay, Now you can see it is coming with no relief. You can see it is coming with no relief. It is directly cut this one from this. Okay, if I will go with this limit left extremity with minimum with square relief, okay, this, and the right side also right extremity, again this preview. Okay, both side it is giving some relief. Okay, again if you want to change with this to some other in extremity, bend extremity, you can go with the according to your requirement, and you can change the value of length 1, length 2. What is the length 1 and length 2, you can see in the figure itself. In the icon itself you can find out the length 1 and length 2. Click OK, preview. Okay, you can see how it is coming like this. So why you are giving this relief? Sometimes what happen now, when we are cutting the sheet metal part and fixing fold it, it needs some relief or some clearance. In that condition we should have give some relief at the time of cut while cutting the parameters. Okay, and the next one is your sketch base. Okay, as it is a wall on a edge, so I need to click on the wall edge first. Here I want to create the one. Here create the profile, and here I have one profile selection, so I will need to create the profile selection here. And you can do this. Let I will just, I want to this type of profile. Okay, I want to this type of profile need to be create on the top. Okay, reverse position. Okay, you can see my profile is created by default by the, without cutting any, without going to any cutting, stamping or stamping tool. Okay, you can invert the direction. Invert means you can see while inverting it is going inside, or it is starting from the tangent to this reverse position also you can. And here you can also define the some relief. Let I will relieve this in the right extremity also. I will relieve this. Okay, preview. Okay, you can see this relief is coming like this. Okay, now so this is how we can create the wall on edge by automatic and sketch based type. Okay, here also in automatic you can find the height. The height will be calculated from the bottom surface of this. Okay, so 37 will calculate from the bottom of this, then it is the from the top surface of the, then from the bend it will calculate the height from the uh, bottom of point, it will calculate the height. There are different types of option where the calculate the height, you can define the height according to your requirement. Up to the plane also you can define. Here you can give the up to the plane like that. Okay, now I think there is completed on this wall on edge extrude or roll. Now the next one is your most important thing is your hopper. Okay, so basically hopper is a sheet metal wall created between two sketch on the parallel plane. Okay, so when you will create on the hop means click on the hopper, it need a to sketch on a parallel plane or non-ruled surface which are continuous to tangency. There are two types of hopper. One is surface hopper, another is conic hopper. Okay, so the conic hopper, it need two profile, as I said, which need two profile which is parallel to each other, and the 2 points, two opening points for open the hopper in sheet metal. Okay, so opening a line is used to unfold the hopper. The line is okay. I'm just going to open the one of the hopper example. Yes, you can see I have two profile. You can see there are two profile which is parallel, which is lies in the parallel plane. Okay, now I will just click on this hopper and conic hopper. Okay, let first one, click the first one and second one. Remember this should be okay. Now we can define the opening line. Okay, you can define the opening line, first line, sorry, first point, this one, second point already defined. You can go with all that also. You can see it is creating automatically. It is just like the mm, multi-section in generative shape design, but in multi-section there are some other factors involved, but here it is involved in the directly in the you can create the thing by using the hopper. Yes, now here if you want to fix the side, I want to fix this side, sorry, okay, I want to import the material, import the material. Import means inside if you want, or outside you can add according to your record. Here you can generate the loft in the band. You can see I can generate the band and the loft, number of band, segment, length you can create in this one by using the generating the band loft. Okay, now the next type of a hopper. Okay, this is what the conical hopper is coming. Then one is surface hopper. If you have a surface, let I will create one of the surface. Let I will delete this hopper. Okay, delete this hopper. I'm just going to the generative shape design for getting the what is that, generative. So multi-section. Let this one is mine, this and this. Close conquer. The boundary is not closed. Where? Close conquer. Carbon is not a close. Okay, I'll do one thing. I will just extract this one. Just extracted. Okay, just hiding this upper. Okay, in this I'll just hide this two and create one of the line by using these 2 point. Okay, now I want to do the hover in a rule based surface, just creating the hover. Okay, now I will create a hover, just inserting another body. I want to create a hover, surface hover. Now I have one surface, it is a surface hover. It is directly taking the reference where, and I want this fold position should be this variety point. Fold position, I need to fold the position, so that I need to create this line over this surface. So just projecting this line over this surface, sorry, support on this preview. Okay, on the line one I need to on hide, and you can see when I will go to this generative sheet metal design and go for the hopper. Yes, now you can see I have just giving this extracted projection. I can define the line of this, just creating the hopper, and I want to open from this edge, or I want to open from this edge. From this edge, it's not coming. I want to edge from this edge. Tier bar need to be remove one of this, remove. I need to define the tier bar where you need to remove. You can define the direction also. Here in other side, I want, yes, the offer coming. Now if I will go to the unfold this offer, it will unfold from this edge. Okay, so like that you can define the hover by using the ruled surface. Now if it is a uniform cross section surface, ruled surface means it is a uniform cross section surface. If it is a non uniform surface, let's non ruled surface, so you can create a hopper from a non-ruled surface. You can create a hopper from any compound curvature. You can see that it is a compound curvature with least possible distortion. So again for that you need to define the thickness and bend radius. Then go for the hopper, surface hopper, select the surface. Okay, and you need to define the tear wire. By default the tier wire is selected here. Okay, I want to tear from this blend edge to. Okay, and click preview. Okay, the input surface cannot be thick. Okay, so I need to give, I see it is not taking this thickness, so I will go with the one thickness one, and go with the this offer again. I want to tear from this preview. Okay, after this, see after this, it is showing the distortion, display the distortion, whether it is when it will unfold, it will break or not. You can see it is not impact much. Everything is correct only. Less impact it is showing here. If you want tear from that point, if I want to tear from this, I will remove this one and tear from this. Okay, tear from this. Okay, it's not possible. Okay, I will tear from this. Okay, you are trying to create a hopper with the tear wire. The select wire is a surface. Okay, and let us select this one from here. You can see it is updating the topology and see it is remove this one. Again, you can to see the hopper distortion. You can see less impact is uh, performing when it will be unfold. Click OK. Okay, and if you want to go for unfold, it is showing unfold. Okay, like this you can go with the hopper. So basically the hopper is all surface are continuous to in the tangency can be used. The right k factor is taken into the consideration of when offset of the rule become non-ruled. Let the right offset. If I will go with the some offset value, if I will go with some offset value, the right offset need to be there. Okay, it's not like you will give any offset. See, it is showing some error. So generally sheet metal is used for standardizing the component. Why? Because it will tell you um, the exact value which is calculated already default, so that whenever you will go with any wrong dimension it will show you the error. Then the next one is your free from the surface or converting sub surface, or we can call this one free from surface, free from the surface. So free from surface is a sheet metal feature that is generating. We can see there are three types of free from surface. One is your free, one is your connected, another is fixed or edge, fixed edge. Okay, so it is generating from the surface, free from the surface, connecting or non-connected or existing sheet metal part. So the first one is free. It is a sheet metal feature from the non-connected feature. So it is a non-connected feature. Means if you have a let, you can see I have one surface. I want to make a surface. So you can go with the hopper. You can go with the surface hopper. Okay, or you can go with the surface hopper, or you can go with this pre-prom. So convert the surface. Here also you will find the same type of feature preview. Okay, understand? Then the next one is your connecting. So you can see. Okay, I'm just on hide this extrude to. This is one of the sheet metal part, and with respect to the sheet metal part, another surface is connected to the sheet metal. Surface is connected. So what I need to do is I want to create a sheet metal connecting sheet metal part. So what I need to do is I will go to the connected and will go to convert the surface with connected one. So select the surface and default. It will take the default and preview. You can see it is taking default one. Okay, it is connecting. Now if you want to go with this on hide, if I will go with the work object and go with the unfold, unfold, you can see it is coming perfectly. Now the next one is converting surface with fixed edge. So let I will create the surface with free, let it is free only. Okay, and if I will go with the unfold, it is coming with this. I want to open this feature, this sheet metal feature, from this fixed edge, from this edge. I don't want to open from this edge. Okay, so what I need to do is I need to convert this one to fixed edge, and I need to select the fixed edge with this preview. Okay, now if I will go with the unfold, it will open from this edge. Okay, this edge is fixed and from this edge it is opened. This is how we are creating the wall or fast wall by using different option. Now the next one is your bending, and the next one is your bending. So basically the second feature which is create in the sheet metal part is created from the piece of metal that is not called that is called to be shape needed, and the fold to be created the required. Okay, that was the fold are known as bend. Okay, so we'll take a small example of bend. Okay, so basically here it is the bend. I want to create the bend between two parts. I want to connect this one. You can see this is one of the wall and this is another wall. I want to create a bend between these two. Okay, so for that one bending option is there. You can select the first and the second. Go with more. You can give the next extremity and the relief. Whatever you want to give the relief, you can go with the relief condition and click OK. Can see the bend is coming. Okay, the folded part. Now I can go with the fold and unfold of the sheet metal part. Okay, then the next type of is second type of bend. It is bend, conical bend. So it is just like the variable fillet in sheet metal design, generative shape design, sheet metal design. So what I need to is I'm just cylindrical. It is cylindrical throughout the bend. It is same, and the dimension will be same. But here in the conical plane, just click on this first one and second one. I want in the left side the radius will be like 17, and the other side it is 6. The second one this. Okay, the left side I want the radius 17. Preview and okay, you can see bend is coming with radius 17 and here it is 6. It is just like a variable fillet, but this time you can go with two corner only, 2 point only. Okay, now each bend from the flat. If you have let you have a flat surface. Okay, let you have a flat component. Let I'm just okay. Let you have a flat one. I want to fold it. Okay, by using this feature. Okay, so what I need to do is go to the bend from the flat, select the profile, line 1 I want to bend with some 1 not 2 preview. Okay, you can see the first one is bent 1 not 2. If I will go with the second one, let I will give some value 102. You can see it is creating the second one also bend from the some angle. Achhe 1 not 2 preview. Okay, so this is how we can bend from the flat. Now the next one is here, and if you have the bend element or folded element already folded and you want to unfold it, so how what you need to do is you just go to this unfold. Here it will ask to you which one to be reference. I want this was my reference, and the face to be unfold this one means it will be here, this will be unfold. Okay, this is my fixed one. With respect to this it will be unfold. Okay, just preview and you can see it is unfold. You can define the angle also for unfold, and I want here 0. I can define the unfold angle 20, like that you can define also. The springing back also you can give. There are normal, fixed and move. Springing back no. See, must be lesser than the angle and the mode. Please modify the input. Fixed radius 77. Natural. Okay, now I want to unfold this one by using this also. Just going to reference, I want to keep this one and it should be unfold. Okay, so I'm just selecting this preview. Naturally it is unfold. Again here I want to unfold. This should be fixed and this should be unfold, like that. You will go to this, go to the reference, see this one and the preview unfold. Okay, but again if I need to fold it again, so what you need to do is you just go to this option. One is folding, so I want to fix this one, and with respect to this I want to unfold, sorry, fold. Go to the again, I want to fix this one. With respect to this should be fold. You can see similarly you can go with this and this to be fold. Okay, like that we can perform this activities. Now the next one is your point or curve mapping. Okay, if you have any curve or diagram mapping, now you can see in the sheet metal design, if I will unfold it, it is coming like this only. Okay, I want to map this to this feature, both this. in this and this. So how to map that one? I'm just on fold and going to this mapping point and mapping, selecting this sketch. Automatic it is taking this to support construction element. If I will characterize the element or engraving, I will go to this, select the one. I want to go for engraving. Okay, want to go for only construction and unfold it to go for characteristic element. Marking, for marking purpose you can define the curve like why you are giving this one and grabbing. User defined also you can define. Okay, user defined standard is not available, but you can define the types. What are the types? I'm not doing for this construction only. Characteristic element or a marking, engraving, you can define that one by using this. And here but default it is taking both the two. If I want to select only this and this, only this you do. Okay, main page I want this only. You can see only one is coming. Okay, and unfold it, you can see only one it is coming in one, it is coming. Now come to the stamping and cutting element. So stamping is or a cutting element is required, giving to give to increase the strength or decrease the weight of the sheet metal design. Okay, so let the first one is you will see, you will cover this one first, that is corner. It is same with your part design. We are generally creating the corner in the edge to matting edge, and it will give you the circular cut. Okay, you can see circular cut. Again same thing you can do in chamfer, but it will give you the flat cut. One is length and length, length and angle. Okay, we'll get this length and length. I want in the first length 6, second length I want like 5. Preview, or you can go with the reverse also, first or second, whatever the thing you want you can reverse and click OK. You can go with minimal or tangency. Okay, now next one is your hole or cutout. Yes, I want to cut this section.
Okay, I want to cut this section from this. So for that I can go with the cutout directly. It is like the pocket, sheet metal standard or sheet metal pocket. Click this one. It will automatically select this one, and you can give the dimension. Sheet metal pocket. It is generally taking the sheet metal pocket. And if you will go to the sheet metal standard, it will show you up to next, up to last anything. Okay, you can see up to last we can perform. Or if you want to go with the sheet metal pocket only, it won't show you this picture. For that you will only have the dimension. Okay, again this hole also, it is similar to the part design. Here the extension is up to next, up to last, up to plane, up to surface. Types of different types of hole is there: simple, taper, you can see counter bore, counter sunk, counter drill. Okay, then here you can find different types of standard. Okay, standard is not available. Tamper. Okay, thread. Here you will find the thin and thin pitch and deformation. No deformation. Deformation you can preview for creating the hole. And this is the circular hole. If I want to cut the hole on this surface, on this circular cut, so you can directly click on this. It will cut this one without going to the any sketch. But here you can also define the point for that. The symbol it is showing, it is a thread one. If I will off this one, you can see the symbol is not showing. Threaded left or right, right thread, right it will come like that. Okay, then the next one is stamping. There are different types of stamping. Generally stamping is used. The stamping is the standard tools which is used to strengthen the material. So in this way you can define that one. What stamping, it is very easy. You just have to click on the profile where you want. Here you will get the surface stamp, bead, then your curve stamp, flange cutout, lower bridge flange. This is very pretty easy because it is a standard thing. If you will give you your dimension, it won't take, it should be perfect. And when you will give you some error dimension, it will show you the error pop up message, it will show you the error. Okay, then the most important thing is one of the important thing is check overlapping. Okay, let if you have a sheet metal part. Okay, sheet metal part, and I want to check this overlapping. You can see while on fold, change the view to on fold. Here you can see 8 overlap as detected. You can see the curve also. It is showing creating the curve on the overlapping part. Okay, this way you can create the overlapping part also. The here one of the important is recognize. If you have a part and you want to make in sheet metal, convert that. Now it is a part body, I want to change to sheet metal part with this folding. So what I need to do is I will go with the recognize. Here in the recognize dimension, it will ask you to the reference. and a wall like 1 2 3 4 5 6 7 let, and I want to ignore this wall while creating this, converting this. And here the band I want this and this, and I want to create the band of this this, okay, like this. And you can see the color is all are different. You can see here while selecting the wall color is showing in blue, band color which already there it is in green, another is in red. Click OK, preview. It will automatically remove the ignore face and it will create the face. In this way you can recognize the wall. Hope you got the concept of this generative sheet metal design. Thank you. Jai Jagannath.